Hello everyone, welcome to another Time Helps video. We'll be starting Mrs. Pearce's midterm review 1 through 10 odds. So in order to solve number 1, we need to first know how to factor. And if you do not know these factoring rules, go ahead and check out my factoring video. It will be in my other websites. I will post a link down below. So the first step that I did before I did anything was to go ahead and rewrite this fraction as getting rid of the division sign. Because whenever you're going to divide fractions, it is best to just multiply them. So this is what I did here. And now for the factoring part and simplifying part. So 5 is going to remain the same. So 5 and what two numbers when multiplied by 6 and added together equals 5, multiplied together equals 6? Well, that would be 2 and 3. So a plus 2, a plus 3 over, looks like this is a difference of 2 squares, 3 times a minus 8, because 8 squared is 64, and a plus 8. A plus 8. And now what you're going to do is you're going to just copy this. Alright, now for the simplifying portion of this. Okay, I see an a plus 3 here and a plus 3 here. Well, when you multiply by anything by 2 over 2 or x over x, it will just be 1. So we can cancel this out and cancel this out. I see an a plus 8 here and also an a plus 8 here, so that's all canceled out. And now this last part might be a bit tricky, and some people may not see this, but actually 3 is a factor of 51. So you can cross this 51 out, but not so fast. You need to rewrite this as times 17. Alright, and now we just simplify this. What I'm going to do is I'm going to take 5 and multiply by 17 and just keep the a plus 2 as it is. I'm not going to simplify because you don't need to simplify. So 5 times 17 is going to be 85 times a plus 2, all divided by 43 a minus 8. Alright, cool. Number 3, for the given graph, describe the end behaviors, determine whether it represents an odd degree or even degree polynomial function, and state the number of real zeros. I'll give you a couple seconds for you to work this out on your own. Okay, so describe the end behaviors as x approaches infinity. Well, f of x looks like it's going towards infinity. F of x looks like it's going towards infinity. Let me write that same thing down here. So for a, as x approaches infinity, positive infinity, f of x is also going towards infinity. And when x approaches negative infinity, we're saying as you go further and further down, it looks like it's just going down forever. So f of x must be going towards negative infinity. Alright, check. Oops, sorry. Better. There we go. Determine whether it represents an odd degree or even degree polynomial. Now you can find this based on the end behaviors. So A will give us the answer to this. Now it doesn't matter how wonky this is or how crazy this will be. It doesn't matter. All it matters is whether the one side of the polynomial is going up and the other side is going down. If they are going on opposite ends, so whether one is going up, one is going down, or one is going down, one is going up, it is an odd degree polynomial. It is odd degreed. If it's an even degree polynomial like x squared, if I were to draw an x squared here like this, oops, you can tell I'm not that artistic, it will have endpoints that will go towards positive infinity or on the same f of x, and therefore it's an even polynomial. But in this case, it is not f of x, so it's odd. State the number of real zeros. Here, let me erase this real quick. Okay. So state the number of real zeros. So we have one real zero here. We have another one over here, another one over here, one over here, and the last one's over here. So we drew 5 circles, so the number of real zeros is 5. Alright, this is to simplify this polynomial. Alright, so just looking at this, it seems a bit tricky, but I think we can get through this. Here's what I want to do just intuitively. I am looking at this and I'm seeing, okay, so x cubed x squared, okay, so that's a clue. So these two are separated by an x squared, and these two are also separated by an x squared. It will kind of give you a hint that you need to group these two together. So let's go ahead and do that. So I'm just going to rewrite this whole thing and just put parentheses around it. So 30 x cubed plus 45. Let me write this 45 better. 45 x plus, in this case, let's make this a plus, negative 50 x squared minus 75. Alright, I want to take an x squared out of both of these, because I just saw that there was a difference of x squared somehow. So there must be something related to x squared. Okay, you know what? Let's forget that idea. Let's just simplify and see if it works out. So I see a big common denominator is 15x. So let's take a 15x out. So 15x. So 15x and now you're going to multiply this by 2x squared plus 3 plus, and now this is going to be the biggest common denominator here is negative 25. Negative 25 negative 25 times negative 50 is 2x squared. Negative 25 times something equals negative 75. That something has to be 3. Look, it worked out. These pink terms are going to be the same, and so what we need to do is we need to make these guys the same and do some simplifying That will be our answer. So let's go ahead and do that. So a common denominator for this is going to be 5. So 5 times, and I'm going to write the pink term first, 2x squared plus 3 times 3x minus 5. Now just to recap what I did. I looked and saw, okay, so this has a difference of x squared, and this has a difference of x squared. I'm just looking at the x's. I don't care about the numbers. So it's worth a shot to group these together. There wouldn't be any harm in doing so. So I grouped them. I simplified each term. I took out a common denominator for each one, and just so happened to be grouped together. Next, what I did was I grouped this term together and this term together, as seen over here, and just simplified by taking a 5 out of each of them. Alright, on to number 7. Find all the zeros of the function f of x. I'll give you a couple of seconds. Zeros, or possible roots that could be available for this polynomial. So let me list out the factors of 54. 1, 2, 54 can be multiplied by 3, can multiply by 6, 9, 18, 27, and obviously 54. And these are all plus or minus. And then for 8 is plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So let's put our thinking caps on and try and think about this logically. So what we can do is we can try this. We can try a very simple number. So 3 divided by 1, and let's just see what happens. So we can use synthetic division. So 3 is going to be in this box here. So 8, negative 49, 93, and negative 54. So let's put this giant line down here and bring down this 8. So 8 times 3 is 24. Negative 49 plus 24 is negative 25. Negative 25 times 3 is negative 75. Negative 75 plus 93 is going to be 18. And 18 times 3 is 54. And again, you just have to guess, and this is 0. Again, you have to guess with these. And there really isn't any better solution to this. So we know that one of the solutions is x equals 3. That's good, but we still have this left to do. So from here, you can actually factor this and do it yourself, but you could still do more synthetic and solve it that way. And that's what I'm going to do here. So we have this, and let's use 2 and 1. Let's keep this simple again. So 2, bring down the 8. 8, 2 times 8 is 16. 16 minus 25 is going to be negative 9. Negative 9 times 2 is 18. 0, 0, 0. Alright, and so x equals 2 is also going to be a solution. And finally, this is 8x minus 9. And so that means that 9 over 8 is also going to be a solution. Remember this 8 better. 9 over 8. Alright, final question. This one it might trip up most students, but I think you got this. I'll give you a couple of seconds to try and work this out. Okay, so the first thing we need to do is we need to convert 1 over 256 into exponent notation. So keep the left-hand side the same. 4 to the 8n minus 10 is equal to 4. Now, do you guys remember what happens when there's a fraction, 1 over something? That's right, it's going to be a negative exponent. 4 to the power of something equals 256. And what could this be? This is none other than 4 to the power of 4. Because 16 times 16 is 256. Okay? So now what we're going to do is we're going to get rid of these, we're going to get rid of these bases, because these bases don't really matter. So get rid of this one base, get rid of the second base, and so we rewrite this equation 8n minus 10 equals negative 4, and now we solve from here. So I'm fairly certain that you Algebra 2 students know how to do this. 8n equals 6, and therefore n equals 6 over 8, or 3 over 4. And I hope that's helpful.